Testing, testing, testing. Yeah, I'm just gonna go ahead and just get started soon. Just need to make sure that everything's set up on my screen before I move forward. Then sounds great. So I'm just gonna go ahead and just get started soon. Just need to make sure that everything's set up on my screen before I move forward. What's going on? Happy holidays. The daily math trading with Khan Academy, Algebra Basics. What I'm trying to go ahead and do each week is provide some sort of like basic training pattern so that I can actually be prepared for more engineering techniques. Yeah. And the idea is to just continue to work on these things every day and hopefully be able to see some sort of like progress. You know, like one of the biggest problems for me is working with the, you know, staying in the habit trying to put these things together. So I'm trying to go ahead and do that with these things every single day. So if you continue to watch, that's great. Other than that, I'm just going to go ahead and get started. So the course challenge is a way to kind of like get all of the work that I already know and get that covered and then focus more on only the ones I don't quite understand. This is probably a better way than actually trying to go through every single one because I'm noticing that I'm falling behind and like meaning that most of the work I should getting done, I keep going back because I'm trying to get a perfect score, which is not necessarily a problem, but it's okay. All right, so let's go ahead and get started. Where did I put this? All right, looking for the pen now. All right, so here. So it's gonna be 30 problems. It says here, y equals 2, -5. Right? And it says complete the missing value to the solution of the equation. And I think we have here 2 common. So it looks like this, what they're trying to say is that we have 2 variables in we have 2 variables in our expression, and one of the expressions already shows 2. Does that mean that 2 could 2 be, what is 2 then? You know, I don't know. I gotta figure out, like, first we can try, what we do is we'll try to see if we can solve for y by getting y x by itself. So we'll solve that by itself. So we'll have x here. We have 2x after we do that. The next thing we need to do is that we can go ahead and we can get 2x over here like this. And that would basically mean, no. Okay. So once we actually have y minus 5 is over 1, how else can we go? Can we do something like that? That brings us, that would bring us back to where we were before. Well, my idea would be to No, actually, this would just be 1. And that would just lead us to 2x over 2 equals y5 over 2, which I don't think we can do because we can't set up those things up there. Yeah, I mean, like, let's see what happens if I go ahead and I say 2 and see what happens. I'm gonna go ahead and wash all this stuff out and just see if I can go ahead and just get the actual numbers to be represented. So we have this, so I'll let 2 equal x, right? And that would be 4 plus 5, right? And that would equal 9, and that would mean y equals 9. Is it that simple? Yeah, that was basically what it is. Okay, so you can see there, that's basically what that is. All right, move on to the next one. How many solutions does the system have? All right, I remember this back in just in high school. So you basically have y equals negative 2x minus 4, and then y equals 3x plus 3. And it tells you how many solutions does this system have. This system would have multiple solutions. Because if let's say if it was 2, and we say 2x to 2x would be 4. 4 minus 4 would equal negative 8, and that would be negative 8. And then that plug that negative 8 in here, that would lead us to negative 6. Oh, negative 6 plus 3, which wouldn't necessarily be equal. So I'm pretty sure it would be an infinite amount of solutions, or then no solutions then. Wow. Okay. So it's actually exactly 1 solution. Wow, I forgot how to do that then. All right, so we can move on to the next one. We have here A, E, D, B. Looks like we have 2 triangles here. This is a right angle, a right triangle. And then here, this whole thing then would be another triangle. Sorry about that. So we're going to solve for x. Thinking about this before, this would be like the Pythagorean theorem, I'm pretty sure, like a squared plus b squared equals c squared. And solving for x, where would x be? X is here. So 3x. Let's say this is A, and this is B, and this is C. Well, we can't. We can make it. We'll make that actually. We'll make this A, and this B, and this C. So that would leave us with that, and then we would have here C squared, or just x squared, right? Which would bring us to 9. I know this 90 degrees probably is a good opportunity to pay attention to that. Oh man. It has to be something about the width here. All right. Don't know. Well, what about this one here? Let's see if this is a. Okay. I think I see what was going on. If this X here, then there has to be some some relation between these two. Because if 3 here, this is 3 and this is 9, can X be considered 4? Well, no, it wouldn't be 4A12. No, it wouldn't be. It would be 6. Well, 6 is times 2 is 36. Yeah, you don't have a square for that. If A to B, if AB is equal to 3 and BD is equal to 9, then we have here D to E is equal to 12. Then you have C to E. I know that there's something about if the right angle. Okay, right. So there's something about the right angle. I'm remembering now. The right angle, a right triangle. These sides are equal to each other. So if this is 12, then this also means that 3 plus 9 equals 12. So that would also mean, so that's great to know that. That's good to know. So that's like, so we could say a squared plus b squared equals c squared. And then we can say that we can work with this one first, where we'll say that this is 12 and this is 12 square. And then we can probably get what do you call it again? This is 288, and then that's equals c squared. Well, it actually won't. It will be something like this. I'm just gonna find the square root real quick. Because if this is a squared and there's b squared, we put that in here. We need to find out 288. Could this actually be 288? This whole thing? What two numbers would give us that? One second. So, and then that, okay, so that also means that this right angle and this right angle is also equal because this is the right angle. So, and then if this is 288, then we can say something about this x equals 3. Yeah. I had to think about that one. Oh my God. Yeah, I knew that these were the clues. These are definitely the clues right here. And because the right angle, these both are equal to each other. So we didn't have to do any other, work with it. That's good. It's good to know. All right, let's move on to the next one. It says, which graph represents 2x plus 5y is greater than negative 4? 2x. I said 10. I meant 10x. 10x plus 5y is greater than negative 4. And then you have here, which graph would actually just help us? Well, both of these angles are going through the origin somewhat closely. So that means that 10x would be, well, we're looking at negative 4 then. So greater than negative 4 would probably be something like this, because over here, this is bigger than negative 4. This one over here doesn't even hit negative 4. It would be considered greater than negative 4, but this number means that this expression here has to mean that it's covering everything past negative 4. Well, it has to cover everything from negative 4 on. So I don't think it would be that. This one looks promising. This one looks promising. And now I have to remember these dots. These dots, forget what this means. I think it means greater. And I think that when you have a line in it, it means greater equal. That's something I forgot. I'm going to omit D and I'm going to omit A because it has to be one of these. The dotted line, now I remember that when you have a circle in it, this would mean less than. And then when you put a solid through it, that means like, that would mean like this or like that, remembering the number line. But the dotted line in here, I'm going to say it's less. I'm going to say that it's going to be B. No. Then C then? No, it isn't either. So I'm totally outside of it. Then let's look at the we gotta look at the hint. 4/5. So what happens here is that we solve for this, we get the negative times 2 is greater than, we get y is greater than negative 2x minus 4/5. And then so you shade above, not below, because y is greater than the other side of the equality. Okay. And we draw a dashed line, not a solid, because we aren't dealing with an equal to an inequality. Yeah, so a dash line would be inequalities. A solid is it says we draw a dash line not solid because we aren't dealing with an equal to inequality. So the dash line indicates the points on the line are not solutions of the inequality. Okay. So that's what it would be. So I felt like the dotted line would be a good opportunity to say that, but then I want to, yeah, so I was actually somewhat wrong. So I have to pay attention to 4/5. It says like we're saying negative 2 is 4/5. So I have to figure out why I did that. Negative 2x. Yeah, I feel like I have to review that. Let's keep going. Find the solution of the number of equations. Negative 2 plus 2y is equal negative 4. So you can find the solution of the system of equations. Yeah, this is called system of equations. So you can use an interactive graph below to find the solution. So this graph here is interactive. I wonder how we do that. I think we set them equal to each other. I don't remember system of equations.